Hello all. Very good evening to you all. I welcome you. I welcome all the students for day 4 of your technical training. Today we are gonna discuss about the topic supervised learning, and we are gonna implement it with them and having hands-on session. I hope I'm clearly audible and my screen is visible. Hello. I hope I'm clearly audible now. So let us begin with our today's topic. Let us first see about our agenda for today's session. So in today's session, we are going to get started with machine learning. So we will be implementing some machine learning algorithms like regression and classification algorithm. And then we will be learning about some of the evaluation metrics in regression and classification that we will be using. So let us get started with machine learning. So in the very first session, in the intro session, so today we are going to learn about regression and classification algorithm and the evaluation metrics that we will be using for each of them. So we will be doing hands-on with regression and classification algorithm. So let us get started with machine learning. So in the very first session, we have explained what is machine learning, right? I hope you all have seen the very first session. So let us revise this machine learning. Machine learning is a branch of artificial intelligence and computer science that focuses on the use of data and algorithm to imitate the way humans gradually improve its accuracy. Basically, in machine learning, we make use of algorithm to make our machine learn from the past data and should be able to predict for future when we give some values, right? So basically we train our machine based on some data. So based on that data, our machine learns the pattern from of the data and gives gives us the output when we give any other input. Hello, hello. Let me reconnect. audible now? Am I audible now? So thanks for your confirmation. So now let us begin with our today's session. I'm sharing my screen now. Yeah. So I hope the basics of machine learning is clear. Now let us move ahead and see the life cycle of a machine learning model. So basically, the first step is to collect the data. The first step is to collect the data on which we are going to train our machine, the data that we are going to use to build our model, right? So very first step is collection of data. So where you can collect the data? You can collect the data from multiple resources that are available nowadays. You can collect the data from online sources, like there are a lot of data that is present online. You can use Kaggle, you can use UCI, and many other websites that you can use to grab the data. Also, you can get the data from real-time market surveys. Also, you can get the data from organizations, right? So after collecting the data, the next step is to preparing the data to implement modeling techniques on it. Preparing the data to implement modeling techniques on it. So basically, my system do not understand any text or something. What my system understands, or any machine understands binary language, that is zeros or ones, or we can say if we give textual data to my machine or to any machine, it will not understand that data. So that data needs to be treated and converted in a format that is easily understandable by machines, right? So we need to transform our data in such a way that there is no inconsistency in our data. Also, our data is easy for machines to understand, right? We need to convert our data in such a way. So that is what we call as data pre-processing, data wrangling, or data cleaning, right? So this is what data pre-processing. This is one of the most important steps that plays an important role in the prediction or in the analysis of your data. Then you have the next step is analyze the data. Then to know your data deeper, like get deeper intelligence on your data, you need to analyze your data. You need to perform EDA on your data, exploratory data analysis on your data, so that you can get to know your data. That is our first step, data analysis. That is our first step, data analysis. Then we have the very next step is train, test the algorithm. Train and test the algorithm. I hope my voice is not breaking now. Hello. So the fourth step is to train the algorithm. After analyzing the data, we would train our algorithm on the data. We would make our algorithm to learn. We would make use of algorithm to learn from data and test test our model. Then we will be deploying the model that we have created. Then we will be deploying the model that we have created. So now, what are the different types of machine learning techniques? we have different machine learning techniques like supervised learning, unsupervised learning, and reinforcement learning. Supervised, unsupervised, and reinforcement learning. So this I have already given you a glance in the very first session, but let us just brush up. So what is supervised learning? Supervised learning is when you are given with a labeled data set. When you are given with a labeled data set. When output to your data, label to your data is clearly defined. When output or label to your data is clearly defined, right? Then you use supervised machine learning. So supervised machine learning is similar like a teacher is telling you this is A, this is B. So you get to learn that this is A and this is B. Okay. Then we have unsupervised learning. Then we have unsupervised learning where there is no label to our data, where there is no label to our data, right? It is like learning by yourself, learning by yourself. So now you don't have any maths teacher to you. You don't have any maths teacher to you. Now you will yourself learn that 2 plus 3 is equals to 5. 3 plus 2 is equals to 5. That this is you are learning yourself. This is you are learning yourself, right? Because there is no teacher to tell you if you add this to this, you will get this. This is addition. No teacher to tell you that this is addition, right? You are learning it yourself and doing it. You are doing it yourself and learning it, right? So when you learn yourself, when there is no label to your data, but you somehow find some pattern to classify it, that is basically known as unsupervised learning. That is basically unsupervised learning. So in unsupervised learning, you are just classifying your data into different classes. You are just making different clusters. You are not predicting anything. You are not predicting anything. You are just dividing it into different classes, or you are just clustering them, clustering the data, right? Then we have reinforcement learning. Reinforcement learning is basically reward-based learning. If you do something good, you will get a reward. But if you don't do something, if you didn't do it correct, then you get negative point. Then you have to do that point, repeat that point until you get it correct. You have to repeat that point until you get it correct. So this is what is reward-based learning, that is reinforcement learning. Now let us discuss different techniques we can use. So the very first technique is regression. So if you guys have attended the very first session, then I have. So regression is a technique for machine learning. So when do you use regression? When do you use regression? When you have to predict from a set of continuous value. When the value that you have to predict is continuous, right? For example, if I am creating a model that predicts the house price, that predicts the house price. So what value may be there in the house price? A, a house may be of 20 lakh, one could be of 30 lakh, 1 crore, 40 crore, 50 crore, 70 crore, like this, right? So what are these, what type of value are these? If we are going to predict price of a house, what are the type of values we are going to predict? It is continuous set of value. It is set of continuous values, right? When we have continuous value to predict from, then we use regression. But when we have classes to predict from, right? So I am saying that this is the person, this is his detail, if he'll buy a car or not, if he is likely to buy a car or not. So there may be two classes. Yes, he will buy. No, he will not buy. So now here I am predicting two different classes. Here I am predicting two different classes. So this is what? This is classification. This is classification. So when we have to predict from different classes, then we use classification algorithm. Then we use classification algorithm. Then we have the second one, that is clustering. Clustering is used in case of unsupervised learning. Clustering is used in cases of unsupervised learning, where we do not have any target. We do not know from which class does it belong, or we do not know any target, any label to the data, right? Then we use clustering. Then we use clustering algorithm. Okay. So now there are some important libraries that we will use while implementing these algorithms. So the first one is pandas. Pandas, I hope you all know about pandas. Pandas basically provide you a great tool for data manipulation in Python. Pandas also makes Python capable of loading data, different type of data, right? You can use any type of, you can load any type of data using pandas, different objects. So pandas provide you with very powerful objects like data frames, series, and panels. Okay, so you can use that to manipulate your data. Then we have NumPy. NumPy is a Python package that stands for numerical Python. As the name suggests, it is used for performing numerical tasks, scientific computing tasks on ND array. So it provides you with very powerful object, that is ND array, n dimensional array. So you can perform n number of numerical and scientific tasks on NumPy arrays. Then we have scikit-learn. It is a package that is that we use, that provides you with a lots of supervised and unsupervised machine learning algorithms. And then we have matplotlib. Matplotlib is used to basically plot your graph and do analytics on your data. To perform visualizations on your data, you can use matplotlib. Now let us start with our main topic for today. This was all revision, guys. So we are first starting with regression. So here we have learned that here you have learned different techniques, right? So first we are going to supervise machine learning technique, that is regression. Firstly, we are going to discuss about regression. So what do you understand with the term regression? What do you understand with the term regression? Regression is a statistical way to establish relationship between a dependent and a set of independent values. Okay, so you may have a dependent variable, that is your target variable, and you can have n number of independent variable. Okay, so you need to find a statistical relationship between the dependent and independent variables, between the input variable and the target variable, right? So in simple way, if you take, so we try to find out the relationship between the output we want to predict based on some input feature, based on some features, we try to predict the output. So we try to find out the relationship between them so that we can predict the value, so that we can predict the target value. Okay, so regression can be of multiple types. So here is a definition of regression. Regression is a statistical method that helps us analyze and understand relationship between two or more variables of interest. So that is what I told you. It helps you to find, it enables you to find the relationship between dependent and independent variables. I hope regression is clear, guys. If you have any query in regression, you can ask. Yes, dependent variable like dependent variable is target variable. Target variable is always one. You can predict one value, but independent variable can be one or more. Now, when to choose regression? When to choose regression? That I have already told you. When you have continuous set of value to predict, then you can use regression. Okay. So if I am saying you need to predict profit of your business, you need to predict profit of your business. What you will choose? Regression or classification? I am asking you to find out what would be the profit in next year for your business. Yes, we will be choosing regression. But when I am asking you if a person I hope I'm clearly audible now. Yeah. So we were on regression. When to choose regression? When we have continuous values to predict, when we have a set of continuous value to predict, then we will use then we will use regression algorithm. Like when we are evaluating the trends or we are estimating sales of any organization, if we are analyzing the impact of price changes, or if we are trying to assess the risk, right? How much risk is there? Or if we are trying to predict the price of something, predict profit. So when we have set of continuous values to predict, when our target variable, that is our dependent variable, is a set of continuous values, then we will use regression, right? And when to use classification, and when to use classification, we use classification when we have different classes to predict from. For example, if I am showing you three images, like different images of some fruits, so I am asking you to classify it into different classes. Okay. So what is that? That is classification. That is classification. If I am asking you if this person if this person will purchase a bike or not, if this person will purchase a bike or not, is it classification or regression? So Mr. Saurabh Kumar, as weather forecasting, weather changes with time, right? And the seasons. So in that case, regression will not be suitable. We would use time series forecasting in that case. So the difference between clustering and classification is a type of supervised learning. Classification is a type of supervised learning where we know that this is orange and this is banana, right? And then I am telling you to classify. Tell me if it is an orange or if it is an banana. I am showing you some fruits and I am asking you if it is an orange or if it is a banana. Okay, that is classification. Now I have given you number of fruits. Okay, and I have told you to cluster them without knowing what that is. You don't know what that is, but you are going to cluster them into different groups. That is clustering. Clustering is when you do not know the target variable, when the output is not given, when you do not have any label to the data. Then it is known as clustering. I hope your query is clear. Now, let us start with our first algorithm. The very first algorithm we are going to discuss is linear regression. We are going to discuss linear regression. So here you can see you have one independent variable and there is a variable that is dependent. There is a variable that is dependent on this. So this would be your target variable. This is your target variable. This is your target variable that you want to predict that is dependent on this is your target variable that you are going to predict. and this is your independent variable. So this target is dependent on this. This target is dependent on this independent variable. Okay. So if you need to find a relationship between both of these, if you find a relationship between linear relationship between both of this is called basically linear regression. This is basically linear regression. To find relationship between dependent and independent variable. Okay. So this is a statistical way to find relationship between dependent or independent variables. Okay. So now you can see as my independent variable is increasing. So there is some change in my dependent variable also. It has increased and it has also increased to some extent, right? So if there some change is observed, some change will happen here also because this is dependent on this. Okay. So if it is increasing and this is also increasing, if this is increasing and this is also increasing. So this is a positive relationship. This is a positive relationship. For example, if your level of experience is increasing, your salary is also increasing. Your level of experience is increasing, your salary is also increasing. This is a positive relationship, right? But now my x is increasing and my x is increasing and y is decreasing. This is known as negative relationship. For example, the sales is increasing and the loss percentage is decreasing. The sales of an organization is increasing and the loss percentage decreasing. So this is a negative relationship. This is a negative relationship. So here are some set of values. Here is some data that is represented by blue dots. Now, between these variable, you need to find a relationship. You need to find a best fit line so that if there is a new data point, so if there is a new value of x, so you must be able to the predicted value of y for that. You must be able to the predicted value of y for that. So how to do this? Let us see it mathematically. Let us see it mathematically. So here what we are trying to do, we are trying to find a linear relationship. We are trying to find a linear relationship. So you all must have seen this equation. You all must have seen this equation. What is this equation? This is a simple equation of a line, right? This is a simple equation of a line that we have studied already in our mathematics in some class, right? So we will make use of this equation to find the relationship between dependent and independent variable. So what is y here? What is c here? What is m and what is x? Y is basically mean of target variable, mean of, or you can take it as y is dependent variable, y is dependent variable, y is dependent variable. What is c here? C is the constant. C is the constant. Now, if you remember the equation, if you remember this equation, then you can all tell me what is M? What is this M? M is the slope of the line. M is the slope of the line. And then this X is independent variable. This is independent variable. Okay. So this X is independent variable, right? So this is the equation that is applicable here in linear regression. So Y is dependent variable, C is the constant, M is the coefficient, or you can say slope, and X is independent variable. X is independent variable. Right? So how to find the value of M? Slope intercept, everyone know, right? Slope intercept you all must be knowing, right? So how to find the value of M? X minus X bar into Y minus Y bar upon X minus X bar raised to the whole square. We all have learned this in our mathematics. Now we will make use of this. Today we will make use of it, right? How to use it for linear regression? How can we use it for linear regression? Let us understand the mathematics behind it. Let us understand the mathematics behind it. So we need to plot this line. We need to plot this line so that we can predict our dependent variable. We can predict our dependent variable. How? Let us see. So yeah, now I am having some set of values. I am having some input value for X, that is 1, 2, 3, 4. This is my independent variable. This is my independent variable. You can take it as level of experience. You can take it as level of experience. Okay. And we have particular salary package for the person. Okay. Salary package for the person. Or you can take it something else. I'm just giving you some example so that you can relate. So this is the value of X. This is my independent variable. And this is Y, my dependent variable. So value of Y is completely depending on only the single variable, that is X. Okay. If the value of X is 1, then only the value of Y will be 3. If the value of X is 2, value of Y will be 4. Right? So now let us plot these points first. So the very first point is 1, comma 3. Then we have 2, comma 4. Then we have 3, comma 2, 4, comma 4, and 5, comma 5. Okay, I have plotted these. Now, let us find mean of X and mean of Y. This is 3 and this is 3.6. Add these 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 divided by 5. There are total 5 values. 15 by 5 is 3, right? And then similarly calculate the mean of Y. Now we need to plot a equation, that is a line that is having the equation Y is equals to mx plus c. For that we have the equation as Y is equals to
m x plus c, right? We have the value of x, like this, take it as x bar and take it as y bar. Mean of x will be this x will be 3 and this y will be 3.6, right? What we need to find? We need to find m. We need to find m, right? How can we find m? We need to calculate this. We need to calculate this. For calculating this, we need to make some steps for calculation. So let us first calculate x bar, then we calculate y bar. So this is x bar, this is x bar, then this is y bar. Now we need to calculate x minus x bar. Now we need to calculate x minus x bar. So 1 minus 3. 1 minus 3 is minus 2. 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Similarly, we need to calculate this y minus y bar, right? So value of y is this, y bar is this. 3 minus 3.6 minus 0.6. 4 minus 3.6, 0.4. 2 minus 3.6 minus 1.6. 4 minus 3.6, 0.4. 5 minus 3.6, 1.4. Right? Now what we need to do? Now we need to calculate this. Now we need to calculate this. Right? Calculate this. Square of this. Square of minus 2 is 4. Square of minus 1 is 1. Square of 0 is 0. Square of 1 is 1. Square of 2 is 4. Right? Understood? Now what we need to do? Now we need to find slope, that is m. Now we need to find slope, that is m. How can we find it? Value of m is summation of all these. So sum all these, sum into sum of all these, divide by this. So what you will get? Let us first multiply both these two. Let us first multiply both these two. Okay. Let us multiply these two. Minus 2 into 0. Minus 0.6 minus minus plus 2 into 6, 12, 1.2. Then this into this, minus 0.4. This into this, 0. This into this, 0.4. This into this, 2.8. Right? Now we need to sum all these values. Now we need to sum all these values and divide with the sum of these. Divide with the sum of these. So sum all these values. What do we get? So this is so cancelled. This becomes 4 here. This becomes 4. And here this becomes 10. This becomes 10. So what do we get as mean? Like what do we get as m slope? 4 upon 10. 4 upon 10. So what is the value we get for slope? We get slope as 0.4. We get slope as 0.4. Right? We got the value of slope as 0.4. So this is done. We have find the value of m. We have found the value of m. Now let us find the value of C. Now let us find the value of C. So Y is basically 3.6. You can take mean of Y, 3.6. M is what? M is 0.4 plus what is C? Oh, sorry, into. M needs to be multiplied with the mean of X. So multiply by 3 plus C. So we need to find the value of C. So 4 3 is 12, 1.2. So 3.6 minus 1.2. 3.6 minus 1.2. This is 2.8. The value of C is 2.8. The value of C is 2.8. Right? Now what? Now our equation becomes for predicting the value of Y at any value of X. At any value of X, M will be this. This will be the equation. This will be the equation into X. Right? Now you can predict value of Y on any value of, sorry, yeah, this is 3. This is 2.4, not 2.8, 2.4. This is 2.4. Sorry guys, this is 2.4, not 2.8. Yeah. 3.6 minus 1.2 is 2.4, right? So now if I want to find, now if I want to find value of Y at any given value of X. Now if I want to check for the value of X is equals to 2, I can get the predicted value. If I put the value of X as 2, I will get the predicted value of Y. I will get the predicted value of Y. So this is what, this is our next step. This is our next step. So in the next step, what we need to do, so this is the equation we have got after finding the value of C. After finding the value of C, this is the equation we have got. Now what do we need to do? Now on the given value of X, so value of my X was 1, 2, 3, 4 and 5. On this given value of X, there was some predicted value of Y. There was some value of Y, right? There is some value of Y. But now we are trying to find predicted Y. We are trying to find YP, that is predicted Y. So if I put value of X in this equation, so I can get the value of predicted Y. So if I put the value of X as 1, so 0.4 into 1 is 0.4 plus 2, 2.4. It becomes 2.8. Similarly, if I put the value of X is equals to 2, so this is the predicted value I get. If I put the value of x is equals to 3. This is the predicted value I get. This is not the original value. This is the predicted value that my model is predicting now. Then if value of x is this will be my output. If the value of x is this, then this will be my predicted y. Right? Right? So now let us plot the original y value and the predicted y value. So the blue dots, if you can see, are the original value. The blue dots are the original value. So when x was 1, originally my y was 3, but predicted I am getting 2.8. When x was 2, originally it was 4, but now I am getting 3.2. When x was 3, then originally it was 2, but I am getting 3.6. When x was 4, originally it was 4, and I am here also I am getting predicted also is 4. Right? Now, if the value of x was 5, then the output y should also be 5, but here I am getting predicted value as 4.4. So are the predicted values same as the original value? No, the predicted value are not same as the original value. So now what should we do? Now we try to find mean square error. We try to find mean square error. Right? What is mean square error? What is the formula of mean square error? The formula of mean square error is original y minus the value of predicted y, minus the value of predicted y. Fine. Summation of this, summation of y minus yp. So y1 minus y1p, y2 minus y2p. That is original value was 3, 3 minus 2.8 plus 4 minus 3.2 plus 2 minus 3.6 plus 4 minus 4 plus 5 minus 4.4. Right? So this is also known as cost function. This is also known as cost function. So what should be our motive? What should be our motive when we are trying to plot our line? This is basically error. We need to minimize this error. We need to minimize this error. Right? Now we have got some equation of line y is equals to 0.4 into x plus 2.4, right? But from that we are getting this much of error. We are getting this much of error. We need to minimize it. We need to minimize it. How can we minimize it? Now, in order to minimize and find a best fit line, in order to minimize and find a best fit line where error is minimum, what we do? We perform second iteration. We perform second iteration. Now, what will happen in the second iteration? Value of my m will be randomly changed. Value of my m will be randomly changed. Previously, when we calculated it was 0.4. But now we have changed. It will randomly, the algorithm will randomly change the value of m to some value. Then we will calculate the predicted value of y, right? Then we will try to plot it. Then we will try to find the error. Then we will try to find the error. If the error is minimum, if the error is minimum, that is selected as the best fit line. That is selected as the best fit line. So here in linear regression, our motive is to find a best fit line. Our motive is to find a best fit line so that we can get most accurate predicted value. We can get most accurate predicted value with less chances of error. Right? So in order to do that, we iterate through this many times. We keep changing the value of m, then the value of c will change, then the equation will become something else, then we will again find predicted value of y, then we will plot it, we will find the error, and we will do this until we get the best fit line. We will do this until we get the minimized error, until we get the best fit line. Right? So now on changing value of m, I got this equation. Then this is the value of c I got. Then again, I will find the predicted value of y. Now this is the equation, right? Now I will find the value of predicted y on the value of x is 1, x is 2, x is 3, x is 4, right? Now again I will try to plot. Again I have plotted. This is the original value. This is the predicted, original value, predicted value, original value, predicted value. This is the second pass. This is the second iteration I am doing. And here also I will get some error. Here the value of error is 1.5. Previously the value of error was 0. So which is best? Previous one or this one? Out of these two, which is best? Previous one or this one? Obviously previous one, where we were getting less error, Okay. So if the value now, if the value of C was M was 0.4, the value of C was this, and this was the error. Now if we change the value of M, if we change the value of our slope to 0.8, this is the value of C, and this error we get. If the value of M is 1, this is C, and this is the value of error. This is the value of M, this is C, and this is error. So which is the best fit line? Which is the best fit line? Which is the best fit line? This one. This one is the best fit line. Now we have got our best fit line. Now you want to predict on the value of x is equals to 10. Now you want to predict on the value of x is equals to 10. If your x is equals to 10, what is the output you will get? You will get 0.4 into 10. That is 4 plus 2.4. You will get output as 6.4. You will get output as 6.4. Right? So this is how you can predict for future values. You can predict for your own values. You can predict for any random value. Is it clear? Is it clear? For those who understood the mathematics behind linear regression, can you please raise your hand? Now this is simple linear regression. Why we change the value of m? Value of m is changed so that we can get a best fit line. So what is our target? Our target is to get the most accurate value, right? So in order to get the most fit value, the most accurate value, we change the value of m and we get some predicted value, then we plot them and we try to find the error. If the error is minimum, then this is best line, right? This is why we do it. I have shown you the formula for cost function. That is summation of original y minus value of predicted y. Original y minus value of predicted y. The purpose of linear regression is to predict values, but here we are trying to minimize the error. So at the end, I have told you if you want to predict the value of y on any random value. So if you want to predict the value of y on the value of x is equals to 8, this is the best fit line. Put the value of x is equals to 8 and you will get your predicted value for y. Right? Now this was simple linear regression. Where we had only one input x. But if we have multiple inputs? Mr. Muhammad, we do not change the value of m. Basically, the value of m will be changed itself randomly. right? If we are doing it manually, we will do it. If we are using sklearn model, we do not need to change it manually. How much increment or decrement? Any random value can be taken. Any random value of m can be taken. See, any algorithm is not 100% accurate. So you cannot find exact value. You can get a near value, you can get most accurate value, but you do not get exact value. In some case, you may get exact value. In some case, value may differ, right? In every case, you cannot get exact value. A model cannot be 100% accurate. There is no ideal model that is 100% accurate. So this is simple linear regression where we had already only one value of x. So we are plotting the best fit line. So you see here, if you see here, I have demonstrated here the best fit line. After some number of iterations, we are getting a best fit line. So this is how our line transforms in different iterations in order to get a best fit line. So now this was when we had only a single independent variable. What if we have multiple independent variable? What if I do not have only x, I have x1, x2 and x3. And on these three my value of y is depending. On these three my value of y is depending. What happened in this case? This is basically multilinear regression. This is known as multilinear regression, where we try to find out a statistical relationship between one dependent and multiple independent variable. When we try to find the relationship between one dependent and multiple independent variables, right? The mathematics behind is same, the mathematics is same, but you need to understand it up to some bit. So we have x1, x2 and x3, and we have taken example of house price. If this is the size, this is the locality, these many number of rooms, then this would be the price. So here what my equation will become? Previously I was only having y is equals to previously I was having y is equals to mx plus c. But now I have multiple x. So my equation will become y plus a constant. A naught is a constant. A naught is basically c, constant. What is a1? A1 is a1 is slope to x1. This is a1, a2, a3 with respective values of x. So a1 is the slope with respect to x1, a2 is the slope with respect to x2, a3 is the slope with respect to x3. Right? Now we will do the same process here. You have these many values of x1, x2, x3 and y value, and you have associated y value to them. Right? What you will do here? Here, what do you need to do? You need to do the same thing. Firstly, you need to find the slopes a1, a2, and a3. How do you find a1, a2, a3? x1 minus x1 bar, x1 summation of all these, like x1 minus x1 bar. Okay. Mm. So x1 minus x1 bar y minus y1 upon x minus x bar. This is x1 minus x1 bar to the whole square, right? Similarly, here you will have x for x2 also, for x3 also. If you find the value of slope, you will get 2, 3 and 4. Okay, you will get the values as 2, 3 and 4. After finding out the slope, what do you need to do? After finding out the slope, what do we need to do? We need to calculate the constant. Then we will find the value of a naught. So the value of a naught becomes 1. Then my equations becomes this. Then my equation becomes this. Now I will find the predicted value of y. Now I will find the predicted value of y. Then I will calculate the error. I will get some error, right? Then I will try to change the slope. So here, if you see, previously we were having only one x, this was x and this was y. So we were getting a simple line, right? But now, we are having three values of x. X1, x2 and x3. And for them, one associated y value. So previously we were getting a line, but now we will get a plane. Here we will get a plane like this. You will get a hyperplane like this. Okay, we will get a hyperplane like this. So this is my original hyperplane. Now I get some predicted value. I get some predicted value that is somewhat here, somewhat here. So now this is the this is the plane from predicted value. So now here, instead of finding a best fit line, we will be finding a best fit curve. We will be finding a best fit curve. Okay, how? I'll show you. So firstly, we will calculate the predicted value of y, then we will find the error, then change of slope, then we will change the value of m, change the value of a1, a2, a3 randomly, then we will get a new hyperplane. We will do until we get the best fit hyperplane. We will do this until we get the best fit hyperplane, right? And how this will look like? This will look like this. The transition will look like this. These blue dots are my original value and this is transformation of the best fit hyperplane. And finally, I will get a best fit hyperplane that will look like this. That will look like this, right? A1 and A2 are slopes for x1 and x2. Similarly, we find out m in the simple linear regression case. Here we will find the value of A1 and A2 and A3. Okay. So now we here our motive is to find the best fit plane. Here our motive is to find the best fit plane. So I hope simple linear regression and multiple linear regression are clear. Let us do a practical. Let us do a practical. For that, I would request my mentor to please share the data set in the group. Here I am sharing in the chat. Can you please share in the group? So guys, I have shared the data in the chat. Now we are going to implement it practically. Now we are going to implement it practically. So I hope all of you have received the data set. Because you need some initial point to start with, no? That is why we calculated initially. After that, we try to find out what could be the best. I hope you all have got the data. Can you please, if you have not received the data, please join the Telegram channel and get the data from there. I'm sharing the data once again in the chat. And I am sharing the Telegram link also, guys. I'm sharing the Telegram link also, and I'm sharing data set also. So I would request you all to please launch your Jupyter notebooks and download the data set. So I am launching my Jupyter notebook. So you can simply type Jupyter notebook on Anaconda prompt to launch your Jupyter notebook. You can simply type Jupyter notebook on Anaconda prompt, and you can see that on your browser, Jupyter will open. Jupyter will be launched. From here, I want to create the notebook. Yes, you can use the Google Colab. Those who do not have, you can use Google Colab. So now my data set I'm going to a folder where I want to create it, right? I have just launched Anaconda prompt, and there I have typed Jupyter Notebook, and then I have selected the folder where I want to create my notebook, where I want to do this practical. So please make sure that if you are doing on Jupyter, then your data set and your notebook must at be the same place. If it is not at the same place, then you have to give the path. So now I am creating a new notebook here. You have downloaded the data, then you need to open Jupyter Notebook. You need to launch Jupyter Notebook and go to the folder where you want to create your notebook. The data set is shared on the group. I would request you to please join Telegram group, and there you can find the data. So let us start, guys. From here, you need to click on new Python 3. You need to create new Python notebook. Okay. Then the very first step is to import necessary libraries. Import necessary libraries. Okay. What are the important libraries we need to import? NumPy and pandas. Import NumPy as NP. Import pandas as PD. Then what is the next step? The next step is to read the data. The next step is to read the data. cloud account, so we can create using cloud. If you are comfortable with IBM cloud account, so we can do it with cloud. Hello. 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 Let us do it on cloud then if you are comfortable with cloud. So I need to log in. Just give me some. Please log into your cloud account till then. I would request you all to please log into your cloud account. I would request you all to please log into your cloud account. Is my screen visible now? Yes, if you want to implement it on your own PC, you can implement it. If you want to do it on Collab, you can do it. If you want it to do on Watson Studio, you can do it. You are flexible to use any of three. If you are about to finish your CUH, then you can use Jupyter, no issue. Right? So after login to your cloud account, you will be reaching here. Then please go to your resource list. Then under software and services, you can find Watson Studio. Click on Watson Studio. Then launch your IBM Watson Studio. Launch in IBM Cloud Pack for data. If you have not created any project, you will get new project option here. But I have created projects I cannot get. So I am not getting it. So I need to go here on the menu and then click on view all projects. Hello. Yeah. So when you go here on this menu, click on view all projects, and then you will be landing onto this page. From here, you will get an option to create a new project. Click on new project. Click on create an empty project. Give the name of your project. You can give any name of your project. You can give any name to your project. Then click on create. You will be landing onto this page after your project is created. Then go to assets. Go to assets. Click on new asset. Go to code editors and create Jupyter Notebook editor. When your project is created, you need to go to assets, click on new asset, go to code editor, add Jupyter Notebook. This pop-up you can see. This dialog box will appear. Here you need to give the name MLR. You can give any name, guys. I'm giving it MLR. You can give any name. Click on create. Click on create. See, the service created in Watson will be having unique name for everyone. If you have not created Watson service, then you need to go to catalog, search for Watson Studio and create it. And if you have created it, then you can find it under your resource list. You do not have to make any change to the runtime. Do not make any change to the runtime. Let it be the default runtime. So now here I am performing the very first step, guys. We are running out of time. So I would request you all to please speed up. So I am importing the necessary libraries. Import NumPy as NP. Import pandas as PD. Import NumPy as NP and import pandas as PD. Run the cell using Shift Enter, or you can run it from here. Now, what is the next step? The next step is to load the data. To load the data, first we need to upload the data on cloud, as we are doing it on cloud. So on your extreme right, you can see a binary option in square, 001, written in square. Click on that, and here you can see drag option to your file. Just simply drag and drop the data set here. The data set name is 50 underscore startup. You can just simply drag and drop it here. After dragging and dropping it, after dragging and dropping it, you will get an option. When it is 100% uploaded, you will get an option to insert to code. You will get an option to insert to code. Just select the cell where you want to insert it and go to this insert to code and click on pandas data frame. Insert to code and click on pandas data frame. It will be inserted. It will be inserted. Now the name of my data is df underscore data underscore 1. This is a big name. I want to shorten it. You can shorten it here. I just want to give it df. I can change it here, df, right? And run this. Run this. You can see df dot head. You can see df dot head. What does df dot head do? If you are working on your local system, if you are working on your local system, then you need to give df is equals to pd dot read underscore csv, start the bracket, and here give give the name, give the name of your data set, like 50 underscore startup dot csv. If it is on the same location, then giving the name would work. If it is not on the same location, then before the giving the name, you need to give the path. You need to give the path. Okay, what does df.head do? df.head give you the first 5 rows. df.head shows you the first 5 rows. Now let us perform some EDA. Let us perform some EDA. So let us get some info about your data. df.info. df.info. This is the information about your data. So you can see there is no null value. And there are total 5 columns: R&D spend, administration spend, marketing spend, state, and profit. So basically, this is the data for the profit, for finding the profitability of the startup. If this much is the R&D spend, if this much is spent on R&D, research and development, this much is spent on administration, and this much is spent on marketing, and the startup is in New York, then this would be the profit. Then this would be the profit, right? This is how you can do it. Now, you got to know info about your data set. Now check if there is any null value. df dot is null. Dot any. Dot any will give you information if there is any null value. So for every column, it is saying false, false, false. False means there is no null value. False means there is no null value, right? Now there is no null value, so we do not need to treat any null value. What else do we perform? What else do we want to perform on our data? There is no null value, we have checked. All the values are present, right? All these columns are required to predict the profit, right? Now there is a column that is state. There is a column that is state. Can a machine understand this column? Can a machine understand value of this column? Textual values? No. What do we need to do? We need to convert these values. We need to transform these values. So now we will be using label encoder. We will be using label encoder. What does label encoder do? So there are 3 different type of states. There are 3 different states. Let me show you. What are the unique value in states? So df state dot unique. You can find the unique value in any column in this way. So New York, California, and Florida are the three values. So let us apply label encoding. Let us apply label encoding. What does label encoder do? Label encoder converts the textual values into numerical value. It will convert the textual value into numerical value alphabetically. So alphabetically, what comes first? Can you please tell me California, New York, or Florida? California will come first. So for California, every value will convert it into 0. For Florida, every value will convert it into 1. Then for New York, every value will convert it into 2. Every value will be converted into 2. Right? So let us apply label encoder. Let us apply label encoder. So label encoder is provided by sklearn. Label encoder is provided by sklearn. So I have already told you that sklearn is a package that provides us with many pre-processing and supervised and unsupervised learning algorithms. So from sklearn.preprocessing, we want to import label encoder. We want to import label encoder, right? After importing the label encoder, see, we are already running out of time. I cannot just spend time on that. I have to cover this. So we have imported label encoder. Now we have to create an object. We have to create an instance of this label encoder. So I am writing LE is equals to this label encoder and parenthesis, right? Now I want to apply this label encoder on my states, on the states of my data. So df of state equals to LE. Now the object for my label encoder is LE. So I will call LE dot fit my data into LE and transform it. Fit underscore transform. What data we need to fit and transform? DF state. We need to transform the data of DF state and store it into DF state instead of DF state, right? Now let us perform this operation. Let us perform this operation. We have performed this operation. Now let us check. Let us check with df dot head if it is performed or not. Now what you can see in the states, you can see the values 0, 1 and 2. You can see the values 0, 1 and 2. sklearn is a package of Python that I have told some time before that it provides us with some functions that we can directly use. If it is showing you that your CUH is exhausted, that means you have used it for 10 CUH, 10 computational hour for this month. You need to wait for a month, or what you can use is you can use Google Colab or Jupyter Notebook instead. Label encoder is a technique to transform your data, to transform your textual data into numerical data. To convert your textual data into numerical data, you can use label encoder, right? Now my data is converted into 0, 1 and 2. Now can anyone tell me what type of data is it? Is it continuous or it is categorical? It is continuous or it is categorical? It is continuous or it is categorical? Mr. Aditya, this is how you can import. Okay, you want to import a file in Jupyter. So simply you can go here and just upload any file you want to import. Or if you want to import a library, if you are saying, then you can just use import that I am using here. Like this, you can import. Yeah. So here these values are continuous value. These value are continuous value, guys. 0, 1, 2, 3, 4. These are continuous values, right? But originally our data was categorical. So we need to convert this into categorical values. We need to convert 0, 1, 2 into different categories. How can we do that? We will use one hot encoder for that. One hot encoder, right? What does one hot encoder do? What does one hot encoder do? One hot encoder will convert numerical value. It converts numerical value to categorical value. It converts numerical value to categorical value. It converts numerical value to categorical value. How it do so? So we have three numerical values, 0, 1 and 2, where 0 stands for California, 1 stands for Florida, and 2 stands for New York. So what does one hot encoder do? One hot encoder will transform my data in such a way that we will get three new columns, that is 0, 1 and 2, right? We will get three new columns. If the state for that column is 0, then this will be true, other will be false. If the state is Florida, then only this will be true, other will be false. If it is New York, if it is 2, that means New York, then only this will be true, other will be false. Right? So this is how one hot encoder works. This is how one hot encoder works. So before applying one hot encoder, we need to divide our data into X and Y. We need to divide our data into dependent and independent variables. So can you guys tell me what do we want to predict here? What do we want to predict here? We want to predict profit of profit of a startup. We want to predict profit of a startup. So profit become the output column, the column to be predicted. So we need to divide it into these four will be our input columns, like these four will be our independent columns, and this will be our dependent column. Right? These are independent and this is dependent. So we need to split it into x and y. We need to split it into x and y. Let us do this. So in x, I want df dot ilog. Ilog is basically integral location of all the columns all the rows I want and column I want from 0, 1, 2, 3, 4. So it works to 0 up to n plus 1. So I need to write, I want it up to 3. So I need to write it up to 4. Right? So I will write here column 0 to 0 to 4 and convert it to values. Get only values of it. Get only values of it. Similarly, I need to do it by df ilog of all the rows and only the fourth column. Only the fourth column. Pratibha, I have already told you, if you are getting this CUH exhausted, that means you have exhausted your account for the month. You can use Jupyter Notebook or you can use Collab. You cannot do anything else. You need to use any other alternative, either Jupyter Notebook or either Collab you'd have to use. So in this way, you can divide your data into X and Y. Now, let me check the shape of X. See, 108 rows and 4 column. 4 column, that means 0, 1, like 1, 2, 3, 4. These 4 columns. Now check the shape of Y. 108 rows and only 1 column. Right? Guys, I would say if your CUH is exhausted, then please try to understand it. Please try to understand it because you will be provided recordings. You can do it later onwards. But for now, just focus to understand it. Okay. So I have splitted it into X and Y. Now let me convert my data. Now, what does one hot encoder do? One hot encoder basically convert numerical data into categorical data. Now, let us apply one hot encoder on our data. Similarly, as we have done for label encoder. Similarly, as we have done for label encoder, we will do for one hot encoder. So, from sklearn dot pre-processing import one hot encoder. One hot encoder. Again, creating the instance for one hot encoder. Sorry, I have mistyped it here. Yeah. Creating instance of one hot encoder. Now creating a new variable Z where I will be storing new created values. So I told you guys what will one hot encoder do. this 0, 1, 2. For this 0, 1, 2, it will create three new columns, 0, 1, and 2. If the value is 0, only this will be true, others will be false. If the value is 1, then only this will be true, other will be false. If the value is 2, then only this will be true, other will be false. Right? So these three new columns will be created. These three new columns will be created. Now let us see. Let us see how it is done. So I am storing these three new columns to Z, to a variable I have created Z. Let us transform our data. Fit underscore transform our data. What data we need to convert? We need to transform this. Now in my X I have 0, 1, 2, and 3. So I need to convert only the third column. So third column means I need to take it from 3 to 4. 3 to 4. All the rows, and column from 3 to 4. 3 to 4 will exclude 4 and it will only contain third column, right? So I need to do it in this way. So from X, I want to transform all the rows of the third column and convert them to array. Now let us check the value of Z. So if you see 001, that means this is for California, Florida, and New York. That means this state is New York. This is California. This is Florida. This is New York. This is California. This is again New York. This is California. This is Florida. Sorry. Right? So this is how our state is transformed. State is transformed. So now in my original X, I have R&D spend, I have administration spend, I have marketing spend, and I have state also. So I need to remove this state. I need to remove this state and add Z here and add Z here. Right? So previously in X, there are 4 columns. I need to delete one column. I need to delete one column that will become 3. Then I need to add 3 more columns. 3 columns of Z and 3 columns of our date X now. So this will become total 6 columns. So how many columns we should have in X? We should have 6 columns if we add this Z and if we delete state. So now let us perform this step. Now let us perform this step. So from X, I want to delete np dot delete. From X, row number, column number third. And because it is a column, so I have to give X is equals to 1. So by default, this X is 0. X is 0 is row and X is 1 is column. So from X, I want to delete third column. X is 1 is for column. So now let us delete it. Now we have deleted. Now let us see the shape of X. Shape of X. You can see 3. Now we need to concatenate. Z with X. So 3 columns of Z will be concatenated with 3 columns of X. So X is equals to np dot concatenate Z and X along the axis 1. Along axis 1, that means column wise. Now see the shape of X. Now you can see we have 6 columns in X. Now what we need to do? Now we need to split our data into train and test set. We need to split our data into train and test set. So for example, we have 100 rows. We have 100 rows in our data. I am I am training it. I am training my model on 80% of data and 20% I am keeping for testing. So on 80 rows, my data will be trained, and for 20 rows, I will test my data, right? So this will happen in training and testing. So let us implement training and testing. So again, we need to use sklearn from sklearn dot model underscore selection. Import train test and split. Now we need to create 4 variables: x underscore train, comma x underscore test, comma y underscore train, comma y underscore test. We need to perform train test split to split x comma y, to split x and y into training and testing set with the test size of 0.2 and random state is equals to 0. Now let me tell you what is this. So train test split is a function that is provided by sklearn by model selection, where we can split our data into train and test based on the test size. So here I have given test size as 0.2. That means 20% of data will be in testing, and 80% will be used for training. So 20% of data is to test, and 80% of data is to train. Okay. So let me run it. Now, if you see shape of X train. So previously there were 108 rows. Now 86 rows, that is 80% of 108 rows. So in train set, we will be having 80% of data. Similarly, set, in test set, we will be having 20% of data. See, remaining 22 will be here. Okay. And this random state is every time when every iteration is performed, you do not want to change like if you have taken x number of rows in test, every time if you will give random state not equals to 0, then every time those value will be getting changed randomly, those value will be getting selected. But here we don't want that, because that can affect the accuracy of the model. So we are giving random state equals to 0. We are giving random state equals to 0. Okay. So we have splitted our data into train and test. Now, what do we need to do? Now we need to train our model. Model building. Now this is the main part, that is model building. So we want to build the model using linear regression, right? So from sklearn dot linear model, import linear regression. This is to import linear regression. This is how you can import linear regression. Then again, creating an instance of linear regression. And now, training our linear regression model on train data. So fitting training data x underscore train and y underscore train. So all the training data you need to give here. All the training data you need to give here, right? We are going to train our model on x train and y train. For these number of input, this is the output. These number of input, this is the output. So we are training our model on this. Let us execute. Our model is trained. Our model is trained now. Now we need to find the predicted value of y. We need to find the predicted value of y. Guys, don't worry. I'll share this notebook in the group. For now, as we are running out of time, already 9 minutes are up. Let us first finish it, right? So here we need to get the predicted value of y. So y pred is equals to, how can we get the predicted value? We just need to use our model and predict. So LR is our model dot predict dot predict. On what values we can predict the value of y? We are predicting it on x test. We are testing it on x test. So these are the predicted value of y. These are the predicted value of y. Now what was the original value? Let us see the original value also. Let us see the original value also. So y, so the original value was this and the predicted value is this, somewhat different. For second, this is the predicted value and this was the original value. So there are some differences. There are some differences. Now we have trained our model. We have tested our model. We need to evaluate the performance of our model. How better our model is performing. How good our model is performing, right? So let us evaluate the performance of our model. Let us evaluate the performance of our model. To evaluate the performance of our model, we use some evaluation metrics. So from sklearn dot metrics, I am importing R2 underscore score. I'm giving ACC is equals to R2 score and ypred, comma, y underscore test. Right? So what is the accuracy I have got? I have got 93% accuracy. I have got 93% accuracy. 0.93 is basically 93%, 93.16% accuracy I have got. Now, if I want to test my model on particular values, I want to test my model on particular values, I can test it. I can test it. So see, I want to give some random values here. I want to give some random values. So how many values I have to give as input? Always give the values in double array. So we need to give 6 values. We need to give 6 values. So first 3 values are of Z. That is our state. Then we need to give other 3 value R&D spend, administration spend, and marketing spend. So let us give these values. So what state you want me to choose? California, New York, or Florida? I will tell you about R2 score. Just give me a minute. Let us do prediction on any random value. Let us choose it as California. So for California, first will be true, other will be 0. Then R&D spend, I am taking any random value. Administration are any random value. For marketing spend, any random value. Now for a startup that is based in California, this is the administration spend, this is the R&D spend, this is the marketing spend. What will be the profit value? What will be the profit value? This will be the predicted profit value. This will be the predicted profit value. Right? So this is how you can make your predictions. This is how you can make your predictions. Now someone has asked me about R2 score. Someone has asked me about R2 score. So now let me show you about R2 score. R2 score is a performance evaluation matrix that tells how better our model is performing. It tells us how better our model is performing. It is basically a scale-free score that implies it does not matter whether the values are too large or too small. R2 score will be always equal to 1. Like the value of R2 score will always be less than or equal to 1. You will not get it greater than 1. No matter what values of inputs are, what is the value of output. So it is a metric that can help you compare your model, that can help you evaluate the performance of your model. So the formula for R2 score is R2 equals to 1 minus performance of your model and compare it with a baseline model. It compares it with a baseline model and tells us if your model is best or not, if your model is performing good or not. So if your R2 score is greater than 0.5, then your model is performing good. If it is less than 0.5, then it is not considerable. Then the model is not considerable. So we always prefer the model to be R2 score of the model to be greater than 0.7. If it is 0.7, it is considered a good model, right? So this was all about regression, guys. We need to cover classification also, but we will cover it tomorrow now as the time is over. So we will share this file with you. We will share the notebook that I have created with you. So I am downloading the model. I will share it with you guys. So if you have any further query, you can post on group, guys. So Mohammed Shahbaz has asked about language. You can use any language for ML. You can use R, you can use Python. You can use any language you prefer. Then we have code after importing linear regression. I'll share the complete notebook. For Z, you need the code. I'll share complete notebook. If the data link is provided, then you can use that data, but that is not, it is not like you have to only use that data. You can use any data. If you are finding any data in, like if you are finding data on Kaggle that is more suitable according to you, you can use that. PPT cannot be shareable. This is a content that is for our using that is for our purpose. We cannot share it. Yes, R2 scores define the performance of your model. So guys, that's it for today. As we have already taken 17 minutes more than the given time. So we will continue tomorrow, guys. We will share this notebook with you guys in the Telegram group. I hope you all have joined Telegram group. If you have not joined, I am sharing the link. You can share it. You can join the group. So thank you all guys. We are ending the session. If you have any further query, you can put on Telegram.